Hi, you guys. Sorry that I'm not able to be with you today. I did get called to jury duty. So here is the recording, and hopefully, I don't actually get selected for a trial and end up being gone a bunch of days. Um, so, again, I'm going to go pretty fast through this. Please pause along the way and make sure that you are understanding and practicing all of these. So the first thing you're going to do is your warm up. Please find your warm ups 417 and 418. You're going to add 419 to it, and then you're going to turn that into the sub. So please don't forget, a lot of you guys did not do that last time and ended up with a missing and then turning it in late. So please do this warm up and then turn in all three to the sub as soon as you're done. So please pause and solve these five. Take about 5 minutes to do that. Hit pause now. All right, hopefully you completed all of those. Here are the answers. Just checking exponents really quick. And then go ahead and pull out your homework. Pause if you don't already have it out. And I'm going to show you the answers for that homework. So pause, find your homework. All right, here are the answers for the homework. And then same thing, I'm going to, hang on. I'm going to have you correct it and then turn it into the substitute, please. So hit pause while you do this. Okay, and then hit pause again. If you haven't turned this into the sub, please make sure you do that. Again, last time I had a lot of homeworks turned in late. I don't think it's because you weren't doing them. I think it's because you forgot to turn them into the substitute. So please make sure and do that before you continue. Our calendar. So here we are today. This is my jury duty. Hopefully I'll be back on Wednesday. We are doing factoring again. So if you have some questions or you're a little bit confused, we can do a little bit of review on Wednesday. Our test 4 is right before Thanksgiving. Yay, it will be a well-needed break. So notes today, we are going to factor expressions, and we're basically going to look at 4 different kinds. Greatest common factors, which is just backwards distribution, when the leading coefficient of a trinomial, so x squared plus x plus c, is 1. What happens when the leading coefficient is not 1, and then a special case, the difference of 2 squares, which is kind of a cool little trick to know to save some time. So again, please make sure you've turned in your homework and warm-ups to the sub. If you haven't done that, pause now before you start taking notes. You should already have the notes sheet from them as well as your homework, so make sure that you fill that out as we go along here. All right, so these are the factoring look-fors. I'm going to do this at the beginning and the end. I'm not going to spend a lot of time on this, but hopefully by the end, you can skim through this and take a look and go, oh, totally get all of these now. So again, we're going to go through backwards distribution, trinomials when the leading coefficient is 1, trinomials when the leading coefficient has a value, and then differences of squares. Excuse me. So first one, greatest common factor. This is backwards distribution. When you're first learning this, you should always prime factor each term. I'm only going to do that on the first one because it's a much longer way to do it. But if you're struggling, then you probably should go ahead and learn the prime factorization of each term, circle those, pull out everything that they have in common, and all the leftovers go inside the parentheses. So we're going to pull out any factors that are in every term and create a coefficient. And then all the leftovers are going to go in the parentheses. Make sure that you check your signs. And don't forget, if you've pulled out everything from a term, then there is a 1 there. It doesn't just zero out. Then you can always check it by distribution. So let me explain what the prime factoring means. What that means is that I would then find the factors of 12 and 18. So 12 is 6 times 2. And 6 is 2 times 3. So 12k is 2 times 2 times 3 times k. That is the prime factorization of 12k. Minus 18 is 9 times 2. 9 is 3 times 3. So 18 prime factors into 2 times 3 times 3. Then we're going to look for all the factors that are in each term that they have in common. So they both have a 2 and they both have a 3. We would circle those. And so my greatest common factor is 2 times 3. And then we put the leftovers inside the parentheses. The leftovers are 2 times k minus 3. Then we clean all that up. 2 times 3 is 6. 2 times k is 2k minus 3. Then really quickly, what we're going to do is we're going to check by distribution. 6 times 2k is 12k. 6 times a negative 3 is a minus 18. And that does check, 12k minus 18. Now, that prime factorization is a lot of work that we don't really need to do. Hopefully you guys can see what common factors there are. And in the next 3, I am not going to do that prime factorization. But if you're feeling a little bit lost, you need to do this step of prime factoring. Okay. And like I said, if you are still feeling a little lost, this is definitely an algebra topic that I'm sure you covered a couple of years ago, but if you're not remembering it, head to the Tutor Center or come find me and I'll go over it with you. All right, so 40 and 64 are our first numbers. And so what we hopefully can see is that 8 will go into both of those. We'll check and make sure that's the largest factor that would go into both of those. Then we have an x to the 8 and an x to the 4th, which means we have x to the 4th in common, and they both have a y. So it appears that that is my greatest common factor between those two terms. Remember, terms are added and subtracted parts. So now basically what we're going to do, and actually here, let me show you this. What basically we're going to do is we're going to divide each one of those by what we just pulled out. So divide by 8x to the 4th y and 8x to the 4th y so that we can figure out what's left over. So 40 divided by 8 is 5. X to the 8th divided by x to the 4th leaves us with x to the 4th left over. Y divided by y is 1. Plus 64 divided by 8 is 8. X to the 4th divided by x to the 4th is 1. Y divided by y is 1. And there is my answer. So if we were to redistribute this, I would have 8x to the 4th times 5x to the 4th. 8x to the 4th y times 5x to the 4th would be 40x to the 8th y. That's correct. So that one checks. And 8x to the 4th y times 8 would be 64x to the 4th y, and that one checks. Right? Next one. Again, hit pause if you need to look at that more or copy that down. All right, next one. We're going to see what goes into all of these. So 7 will go into all of them, and then the most or the least m squares that I have is m, or the least m's I have is m squared. So 7 goes, so we're basically dividing by 7m squared, divide by 7m squared, divide by 7m squared in order to get our leftovers. So 14 divided by 7 is 2. M to the 6th divided by m squared would leave us with m to the 4th. Minus 35 divided by 7 is 5. M to the 3rd over m squared leaves us with an m. Minus 7 over 7 is 1. M squared over m squared is 1. 1. This is really important. Do not forget that there is a 1 there. So then I could check by distribution. 7m squared times 2m to the 4th is 14m to the 6th. 7m squared minus times a negative 5m is a negative 35m to the 3rd. And 7m squared times a negative 1 is a negative 7m squared. Okay, next one. We're going to pull out, we can't pull out the 3, the 5, or the 8. There's no common factor there, but they do all have an A, and they do all have a B. So divide by A, B. That leaves us with 3B. Divide by A, B. That leaves us with a minus 5A. Divide by an A, B. That leaves us with an 8. And again, as always, double check by distributing. Let's see, that would be 3ab squared minus 5a squared b plus 8ab, and it works. Oh, sorry. Again, always pause if you're not done and make sure that you're getting all of those notes. All right, this next little section, I want you to pause and try these on your own. This is not, it shouldn't really be an option. I want you to actually do this. And then when you finish, push play and check your answers. So there's a space down there. Since there were 6 of them, I did 1, 2, 3, and then 4, 5, 6. And it all nicely fit in that little section down below. Please pause now and try these 6. You can't learn math without practicing math. So don't skip this. All right, hopefully you finished all of those. Here are the answers. Please check your answers. Go back and fix any that you missed. All right, here we go. Part 2, leading coefficient when it's 1. So we're going to have 3 terms, which makes it a trinomial, an x squared plus an x plus a number. We're going to split that into an x plus something times an x plus something. If there's a greatest common factor, we're going to factor that out first. I don't think I have one for you, not in these examples. Then we're going to list all the factors for the constant, which is C, and choose the pair of factors that add or subtract to create B. The X method works. That is not how I typically set it up, but if you learned how to do it that way, you'll see how you can use that in comparison to the way that I'm going to work it. And then make sure you check your signs. If there are 2 variables, which I think we have one in here, yep, there's a C and a D. If you have 2 variables, you're just going to split those variables, and then always check your factoring by FOIL. We're not going to spend a lot of time checking the factoring by FOIL. I'm going to kind of do it in my head really quick to make sure I didn't make a mistake. So here we go. Our first step is we need to factor out 35. So this is where that X piece would come in, but here's how I do it. I look at 35 and what are all the factors. Now, when you first start off doing this, you're going to do them all. You're going to say 1 times 35. 2 doesn't go into there. 3 doesn't go into there. 4 doesn't go into there. 5 does. 5 times 7. 6, 7. Then it starts to repeat backwards. And those are our choices. Now we need to figure out, we can add or subtract to get to a positive 2. All right. So in order to get to a positive 2, I need a plus 7 and a negative 5. So we're going to go x minus 5 and x plus 7. All right, take a look at that. Then we can FOIL this. This would be x squared minus 5x plus 7x minus 35. And a minus 5x plus 7x does give us what we wanted, which was a plus 2x. So we're good. All right. Again, I said I wasn't going to spend a lot of time on FOIL. If you still need to practice FOIL, maybe try the box method there. All right. This one, we need 45. So we need all the factors of 45. So 1 and 45, 2, 3, and 15. We're looking to add or subtract to 14. So 4, 5, 5, and 9. There it is. So we're going to need a plus 5 and a plus 9. So we have x plus 5 and x plus 9. And then we would just check our factoring by FOIL. X times x is x squared. X times 9 is a plus 9x. X times 5 is a plus 5x. 5 times 9 is 45. This does get us back to our 14x. So we're good to go there. Number 7. 7 is we need our 26. So for 26, we're going to do 1 and 26. That's not going to add or subtract 15. 2 and 13. There it is right away. So in order to get a negative 15, we're going to need a negative 2 and a negative 13. So W minus 2, W minus 13. And we can check by FOIL. That's W squared. That's minus 2W. That's minus 13W, which does check to a minus 15W, and minus 2 times minus 13 is a plus 26. That worked. So this one, we're going to do 48, and notice that we need to deal with that D squared as well. I'll show you how to do that in a minute, but let's figure out what our numbers are. So 48 is 1 times 48. We're looking for a 2. 2 times 24. 3, 8, 9, 10, 11, 12. So 3 will go into it. 3 goes into 4 once. 3 goes into 18 6 times. Nope. 4 goes into 48. 1, 2 times. Still no. 5 doesn't work. 6 times 8. Oh, there it is. 6 and 8. But I need a positive 2. So this is going to be a plus 8 and a minus 6. So here's where we're going to notice the D. So we have C minus 6. That D is going to get split. And I think I put that in the directions. Let's back up. Yeah. If there are 2 variables, the variable is usually just split. So the X and the Y get split between the 2. When we FOIL this, we'll see that that works. So we had 6 minus 6, C minus 6D, and then C plus 8D. So checking by FOIL, C and C is C squared, minus 6D C, so I'm a little backwards, but that's okay, and then a plus 8, we'll keep it the same, DC is going to be a plus 2, and then I'm going to put them in alphabetical order, CD. So, oh my gosh, I have to fix that in your notes. I'm going to do that before I print them today. That was my fault. And then, and then minus 6D times 8D would be a negative 48D squared. So that should be fixed in your notes. I apologize for not noticing that earlier. All right, here's your chance again. I want you to actually do these 4. Please hit pause. Don't get distracted. Do these 4 because otherwise you're going to run out of time. So hit pause now. All right, I'm hoping you worked those 4 and didn't just skip this part. Remember, the only way to learn math is to do math. So here are the answers. Hit pause, check your work. All right, factoring trinomials with a leading coefficient. So we're going to have 3 terms, which makes it a trinomial. If there's a greatest common factor, let's see, 4, 6, 5. Nope, we're not doing a greatest common factor on any of these, but I think there is one in the practice. So multiply the leading coefficient A and C. So what we're going to do is we're going to start by multiplying A and C. So I'm just going to mark up these first 2 so that we remember what we're doing there. Then we're going to figure out what AC factors to create add or subtract into B. So we're kind of back to the original. Our starting number is going to be a little bit different. Then here's the new part. So you're going to divide each number by the leading coefficient of A, and then reduce or divide or cancel. And then that denominator goes to the front of the variable. Now, if you've never done it this way before, this is a cool way to do it that works every single time, but it's going to take a little practice. Okay, so let me show you how this works. So the first thing is A times C. 2 times 18 is 36. Oops, I should be doing this in black because you should. There we go. I'm just doing my checks in blue. 36. So I need a pair of factors that adds or subtracts to 15. Okay, 1's not going to work. 2 is going to be, let's see, 1 and 16 is 8. Nope. 3 and 12. There it is. Okay, so 3 and 12. In order to get minus 15, I need a minus 3 and a minus 12. So here's the next step. Now, this is not going to be the solution. This is our initial setup. So we're going to say x minus 3 and x minus 12. That minus 3 and minus 12 would get us to the minus 15. Now, here's where those stars come in. We're going to divide the number, just the number, by the leading coefficient, 2. Divide the number by 2. Then we're going to reduce, divide, or cancel. So x minus 3 halves is just x minus 3 halves. But look at this one. This one is going to be x minus 6. 12 divided by 2 is 6. Awesome. Next step says move the denominator, any leftover denominators, to the front of that variable. So this is going to be 2x. This 2 comes in front of the x minus 3. Basically what I'm doing is I'm just scaling that up. So if I double that whole factor, I double it, that gives me a 2x plus 3 halves times 2, which is just 3. Now this one I don't have to mess with. This one is already taken care of. There is no denominator. So let's scoot this down and let's just do a quick FOIL here. So 2x times x is 2x squared. Minus 3 times x is minus 3x. Minus 6 times 2x is a minus 12x. And minus 3 times a minus 6 is a plus 18. These two come together and become minus 3 minus 12 is a minus 15x. And we are right back at the beginning there. Okay, so let's do these for practice. Make sure that you are looking and copying and thinking, or maybe even pause and try this before I do it and then check your work. Okay, so 3 times 40 is 120. We're not concerned about signs right now. We need to find the factors of 120 that add or subtract to 19. Okay, 1's not going to work. 2's not going to work. 3 is going to be too big. Let's start at like a 4. 4 goes into 12. That's 30. I'm still way off. 5 will work. 5 goes into 12 twice. 5 goes into 20, 24. Oh, there it is. So if I go minus 24 and plus 5, I'll end up with a negative 19. So here's the first step. Remember, this is not the answer. We have h plus 5 and h minus 24. Now we need to use this leading coefficient and divide the numbers. We can see that 24 over 3 is going to clean up nicely. That h plus 5 over 3 is not going to clean up at all. So what we end up with, I don't want to skip. At this point, you could probably skip this step, but I'm going to keep writing this. So we end up with an h plus 5 over 3. So we have a denominator we'll have to deal with in a minute. And this is h minus 8. That one cleaned up nicely. Now this denominator is going to become the coefficient for h. So it's 3h plus 5. I basically scaled this whole thing up by 3, right? So 3 times h, 3 times 5/3 is just 5. But this other one, I don't need to scale up at all. H minus 8 is just fine. If I were to FOIL check this, that'd give me 3h squared plus 5h minus 24h, which is negative 19h, and minus 40. So that worked out. All right, stay with me here. This is probably one of the hardest ones if you've never done this before. So 6 times 21, 6 times 1 is 6, 6 times 2 is 12. So we need 126. We need factors that are going to add or subtract to 5. All right, 1's going to be too small, 2, 3, 4. Let's start with maybe a 6. 6 goes into 12 twice. Once, 6 and 21's too much. 7 won't go. 8. 8 will go into 12 once. Carrier 4. 6 times 8 is 46. There's 6. Oh, no. Sorry. 8 goes into 12 once. Carrier 4. 6 times 8 is 48. No. Does 8 even go in there? Sorry. 8, 46. No. Okay. So 9. Let's see, 6, 7, 8, 9. Ooh, 9 will go in there. 9 goes into 12 once. That carries your 3. 9 goes into 36 14 times. There it is. 9 and 14 is going to make a 5. All right, so we need a minus 14 and a plus 9. Remember, not the answer, just the first step. Y plus 9, y minus 14. Now we got to snag that leading coefficient, divide by 6, divide by 6. We need to reduce those fractions. So y plus 9 divided by 3. Oh, sorry, my pen's not very good for this. Little work. 9 divided by 3 is 3. 6 divided by 3 is 2. That's as small as I'm going to get. That's the reduced fraction. And then y, this is going to divide by 2 and divide by 2. This is going to be minus 7 over 3. So this first one, I'm going to scale up by a factor of 2. And the second one, I'm going to scale up by a factor of 3. So that brings the 2 in front of the y, 2y plus 3, and brings the denominator into the coefficient of the y, 3y minus 7. There it is. 2y times 3y is 6y squared plus 9. Right here. We're going to go plus 9y minus 14y, which works out to my minus 5y. So that worked. And then plus 3 times a negative 7 is a negative 21. Whew. All right. So let's do this one. Nothing comes out of there. No. So no greatest common factor there. But 9 times 4 is 36. Let's switch. Okay, 36. So we need something that will be 12. Well, that one I see right away is going to be 6 times 6, a negative and a negative. If you didn't see that, go through all the factors. All right, so we're going to ignore the 9 for now. We're going to go x minus 6 and x minus 6. Then we're going to divide by the leading coefficient, right? Then we're going to reduce. 6 divided by 3 is going to be x minus 6 divided by 3 is 2, 9 divided by 3 is 3. That's a reduced fraction. And then these actually ended up being the same, so this is going to reduce in exactly the same way. So what I'm going to end up doing is scaling the first one up by 3 and the second one up by 3. What that gives us is 3x, right? The denominator comes and becomes the coefficient of the x, minus 2, and 3x minus 2. Check it, FOIL it. This would be 9x squared. This would be a 6x minus 6x, which is a minus 12x. Perfect. And negative 2 times negative 2. Oh, I missed the y. There's a y in here. Y. So this is an xy. Let's go back to blue. So xy minus 6xy minus 6xy. That's why it's always good to FOIL. Okay, just double check that your final answer, which is 3x minus 2y times 3x minus 2y, which you might recognize as 3x minus 2y squared, is an even better answer, but either way works. All right, this is your chance, okay? This point, you are probably getting pretty close to the end of class. I want you to still try these. You need to stay focused and get these done. Please hit pause and do these. If you do end up running out of time, please finish this video at home and do the remaining work. Okay, you need to have this done by the time I see you on Wednesday. All right, this one, here are the answers. So check those, hit pause really quick, check what you did. Watch that sign on that bottom one. I realized that -1 times -3 does equal 3, but it's a positive 3. Okay. Differences of two squares. Hopefully you recognize this, and this is pretty easy. So first up, it has to be a binomial, which means it's two terms. You're going to have an ax squared minus a c. One has to be positive and one has to be negative. And one of the ones that I'll show you later is what happens. We could do a negative ax squared plus c, and it will work also. Okay. But usually C is going to be the subtracted one. A and C have to be perfect squares. So in the warm-up today, we talked about what are all the perfect squares so that we can take the square root and get a whole number. So we're going to factor out any greatest common factors first. We do have a greatest common factor here. So we're going to make sure and pull that one out. The rest of them don't. We're going to use the square root of each term. We're going to add one and subtract the other so that B cancels out. And you're going to always check by factoring by FOIL. So these are pretty quick. Let me show you why this works. So 16x squared is actually 4x squared minus 5 squared, right? 4x squared, 4x altogether squared is 4 squared and x squared, 16 squared. Sorry, 16x squared. And then 5 squared is 25. So what that does is that gives us a 4x plus 5 and a 4x minus 5, because what we need is that b to cancel out. So this is going to be a 16x squared plus 20x minus 20x minus 25. Those b's are going to cancel, leaving us with 16x minus 25. All right. So these get pretty easy. They're kind of nice. We do need to watch this greatest common factor here. So we're going to pull out a 3 first. That leaves us with x squared minus 25. Well, the square root of 25 is 5. So we have 3 times x plus 5, x minus 5. Now, unlike the problem that we did on the last set, this is an x plus 5 and an x minus 5. Those are not the same. We're not squaring x plus 5 or x minus 5. Those two have to stay separate, but that's our answer. All right, so now let's take a look when the leading coefficient is numbered, just like in 13. The square root of 9x squared is 3x. The square root of 25y to the fourth is going to be a plus 5y squared, and 3x minus 5y squared. Nice. So the square root of 9x squared is 3x, and the square root of 25y to the fourth is 5y squared. Pretty easy. If we were to FOIL that, you would see that you would cancel out the plus 15xy squared minus 15xy squared, and it would just leave you with our original. All right, this one. So if we look back and remember, this is going to be mn squared minus 7 squared, right? So we have an mn plus 7 and an mn minus 7. If we were to FOIL that back out, we would cancel out the 7mn minus 7mn, and it would give us back our original. This one has a greatest common factor. So we need to slow down a little bit and look at what they have in common. So first of all, I can pull out a 2. I can pull out an a squared. I can pull out a b. So if I pull out the 2a squared b, that's 1. Minus 2 goes into 32 16 times a squared, and the b came out. Here's the example that I told you in the notes, that sometimes you can have a negative ax squared plus c and it still works. Let's look at this one. So we still have the 2a squared b, and then we're going to have the square root of 1 is 1, plus the square root of 16a squared is 4a, and 1 minus 4a. FOIL that out and you'll discover that you get back the original. So here's your turn. These are the last set. So hopefully you still have a little bit of time in class. You can do these fairly quickly. I will tell you that there is a trick on one of them. So please hit pause and try these. If you are out of time, then try these at home before you watch the end of the video. Give this a shot, right? I want you to make sure that you're understanding what's going on. So please hit pause. All right, hopefully you actually did these. Here are the answers. The trick was number 6. You can't do number 6. One has to be positive and one has to be negative. But I put a little but down at the bottom. What if it was negative x plus 25? Then we could say negative x squared plus 5 and a positive x plus 5. So maybe the easier way to think of that is the 5 is what came out nice and neat, minus x, and the 5 is what came out nice and neat, plus x. That actually would work if this were negative, but x squared plus 25 does not work. There is no solution to that, at least not yet. Okay. And in number 5, it doesn't matter if you put xy or yx, whichever. Okay, so now I want you to look back at this and see if you can make sense of it. So please hit pause and take a look at those examples. This little piece right here is to remind you to do a times c to figure out those factors. So you're looking for the factors of negative 6 there that would add or subtract to 5. Okay. And today's objectives, think about, can you do greatest common factors? What happens when the leading coefficient is 1 or not 1? The difference of 2 squares. And now you've got a homework 4.19. Don't forget the greatest common factor. There's one pretty early on that if you forget that, it'll come out with a really weird answer. So make sure that you're checking for that. Hopefully I don't get a trial, and I will see you guys on Wednesday. Regardless, please make sure that you have understood this video, that you tried all of those problems, and that you have homework 4.19 done when you come on Wednesday. Bye.